In class activity 18A, graphing rational functions. The following graph of the rational function f was introduced in preview assignment 18A. 1. What were some difficulties you had in determining the zeros and asymptotes of the graph? Well, the scaling and extra vertical lines made the graph difficult to read. In particular, the graph is not pictured at the scale between x equals -2 and x equals -1. And while it's clear that there is at least one zero between x equals 1 and 4, x equals 1 and x equals 4, there's not enough detail to identify what that zero is exactly. Objectives for the activity. You will understand that technology cannot always be relied on to make good decisions about how to present a graph. Sometimes a hand-drawn graph can be more effective in presenting important data than a computer-generated graph. You will be able to identify common limitations in computer-generated graphs of rational functions. Since f is a rational function, it can be expressed as f of x equals p of x over q of x, where p and q are polynomial functions. 2. The graph of p, which is the numerator of f, is shown below. The viewing window has been adjusted to show all of the zeros. Let's scroll up here. 1 second, it's not moving. Hold on. Okay, here it goes. I'm going to leave 2 right at the top there. Okay. Can this graph be used to determine the zeros of f? Explain. Well, the function f can have, the function f can have only zeros at x equals 0, 2, or 3. So let's write that here. Function f only zeros when x is equal to 0, x is equal to 2, or x is equal to 3. And since these could be holes in the graph or vertical asymptotes, we cannot make any conclusions without also knowing when the denominator is 0. So part 3, the graph of q, which is the denominator of f, is shown here also as follows. The viewing window has been adjusted to show all of the zeros. Part A, it says describe the zeros of this polynomial, where they are, which are turning points, places where the graph touches but does not cross the x-axis. So we could state here for part A, the zeros are when x is equal to -2, x is equal to -1, 1, and 4. And we could say no zeros are turning points. Part B, I'm just going to scroll up a little bit here. Part B, it says using the graphs of P and Q, determine all zeros and vertical asymptotes of the rational function f. Well, the function has asymptotes or holes. Okay, I'm just going to write that here. The function has asymptotes or holes. It's an S, there we go. Or holes when x is equal to -2, -1, 1, and 4. Now, since none of these match a 0 in the numerator, all 4 of these are vertical asymptotes. So we can say all of these are vertical asymptotes. And a little bit more, let's scroll up again. The zeros of f will occur at x equals 0, x equals 2, and x is equal to 3. Number 4, the graph of f of x over p of x equals p of x over q of x is shown We have zoomed out so that the graph is plotted over the interval -100 to 100. And that's on the next screen here. So let me scroll up a bit here. And there it goes. So there's a picture of the graph, and it's really zoomed out there. Based on the graph, what can you say about the zeros and asymptotes of f? Well, at this scale, let's see. At this scale, the zeros and vertical asymptotes, they can't really be determined. The zeros and cannot be determined. But there's it looks like there could be a horizontal asymptote. So the graph seems to have a horizontal asymptote. When, let's see, looks like it's going to be 1. So y is equal to 1, that horizontal line. Let's go on to questions 5 and 6, or numbers 5 and 6. What do you know about the function f at this point? Well, at this point, we know the zeros, and we know the vertical and horizontal asymptotes. The zeros and the vertical and horizontal asymptotes. Let's see. Let's just collect all this information. It seems to have zeros when x is equal to, what do we say? 0, 2, and 3. I'm going to abbreviate here, VA for vertical asymptotes, when x is equal to -2, -1, 1, and 4, and horizontal asymptotes, and we said y is equal to 1. 6, what additional information would you need to draw the graph of f? Well, we don't know exactly what the graph of f looks like at the zeros and the asymptotes. Having more information about the behavior of the function around these locations would allow us to get a more complete graph of the function. That is the end of this video.